Hi guys, welcome back to 145 chapter 2. Your chapter 2 will be scalar and vectors. So we start by looking at scalar first. Okay, your scalar quantities are physical quantity that only contains one information, which is the magnitude. Or in other words, the size of the physical quantity that is measurable. Alright. So, example of scalar quantity. For example, time. Okay, time. Maybe someone will argue that time can be forward or backward, like go to the future or back to the past. Well, at the moment, we don't talk about that yet because your level understanding may be not that deep yet. So we leave those time travel alone first. Okay, that one we discuss some other time. So time is one of the example. Number 2 will be mass. Okay, or we pronounce as mass. So mass is a physical quantity that does not concern direction. So mass is something that cannot change. It is fixed whenever you go, okay, in the whole universe. But when I say that is, we are talking about rest mass. Okay, we are talking about rest mass, a mass that does not change to energy, right? So unless you are talking about something in a nuclear reaction, then mass and energy is a constant, but not only mass. Okay. Then other than that, you might have heard something like distance. Okay, distance is quite the same as displacement. If we talk about magnitude, but displacement have one information extra, which is a direction, but distance no. Okay, and then last one will be speed. All right. So speeds are something that only concern how fast you are moving, without concerning the direction in which you are moving. So for example, if you are caught by police saying that you are over the 90 km/h, you can actually argue with the policeman that in what direction. Okay, but unless the signboard saying the speed limit is, it use the word speed limit 90 km/h, so you got no argument with that. But unless the signboard said that the velocity limit is 90 km/h, if it didn't say in what direction, then you can argue with a policeman. But don't try to do that with our police here. Okay, you might end up in a lot of trouble later, right? And don't show up your physics also. Okay, so these are examples of scalar quantity. So scalar quantity use normal algebra to solve. Okay, like x plus y, 2x plus minus 7y, and so on. These are normal algebra. Okay, because it is something that is very simple. Alright, so normal algebra you already learned. For example, normal algebra will be 2 kg plus 4 kg give you 6 kg. No matter how I sum them up, 2 first followed by 4, or 4 first followed by 2, you still end up with the same answer, 6 kg. Okay, but if we apply that concept to the next quantity, which is a vector quantity, is not entirely correct, because vector quantity contains another information, which is the direction. So that's why in vector quantity we have another way to solve vector problem. Okay, so that is our first one, scalar quantity. Okay, scalar quantity. Now next one, the second one will be our second quantity, which is the vector quantities. Okay, so vector quantity contains extra information. So this one contains magnitude and direction. Okay, magnitude and direction. So that means one vector quantity contains more information than one scalar quantity. Okay, so that's why usage of vector is important in physics, because in physics we try to give information as compact as possible. So when someone read your information, they know what you're talking about. Alright. So vector is one of the most important one, especially when you come to the next topic. Okay, chapter number 3. So example of vector quantity. Well, the first one I can give you displacement. Okay, displacement, change of position. Okay, change of position. And then number 2, well, related to this one, speed, is the velocity. Okay, velocity. So that means you are moving at how fast in a certain direction. Okay, that one is velocity. Another one will be something like force. Right, force is very common. So force is something that can make something move faster or make something become slower, or it can change the direction of the object, and it can also like change the shape of object. Okay, if the object is changeable. Alright, so that is force. So these are examples of vector quantities, and you can only solve vector quantities use vector algebra. Okay, use vector algebra. Alright, so now meaning of vector algebra, for example, example of one of the vector algebra problem is like, for example, you're walking 3 meters to your right hand side, or we call it east. Okay, and then you move again to another south, but now you walk 4 meters. Now this is your starting point. You start here and then you end here. So in physics we normally call it initial point, and this one is the final point, or starting and ending point. So if I ask you the distance travel, well, distance is a normal, what we call it, is a scalar quantity. So distance is easy, 3 plus 4. So your total distance is 7 meters. Okay, but if I ask you something like displacement, your displacement is the shortest possible path between 2 points. It must start here and then end here. So the shortest point is a straight line between this initial and ending point, and the direction is from the start to the end. So we use an arrow to represent that particular quantity, and this one is 5 meters. And your displacement, the symbol we use normally is S, is 5 meters. You are not only telling people that your displacement is 5 meters, but you also have to tell people in what direction you are moving. Well, this is your direction, angle theta, because this one is definitely not southeast, because the southeast is 45 degrees. Okay, so this one is not southeast. That means you have to use trigonometric function to calculate the value of theta. In this case, you can use sine, cosine, and tangent. Okay, but magnitude is 5. Alright, so that means you see, vector algebra is going to involve more calculation in every one of the question. Alright, so the next one that we're going to look at is, how do we represent a quantity of vectors? Okay, so now is still under vector. Now is the symbol of vector. Okay, symbol of vectors. So our symbol of vectors is very easy. For example, I can say that my displacement is pointing to the east. So that one is east, and the magnitude, okay, the length of the vector is the magnitude of the vector, and the direction, okay, the direction of arrow is the direction of vectors. Okay, so you have, the longer the vector, the arrow, the larger is the quantity. Okay, and then the direction represent in what direction the quantity is changing or is pointing to. So that one is the way we symbolize vector in drawing. So an arrow with direction. Okay, but you throw away the feather behind here, okay? We don't need that now. So that is one of the the easiest way to represent a vector quantity. Alright. Now, another example will be something like this. Let's say you have a quantity. You are driving a car, moving with a certain velocity. Okay, at a certain velocity, let's assume this horizontal line represents the direction to the east, and this one is of course to the west. Now let's assume that you are running your car at 45 degrees in that direction, below that line. Okay, below that line. Let's assume your velocity is, let's say, 20 meters per second. So this 20 meters per second in this direction is a velocity. Okay, but there are so many ways you can tell people about your direction. You can say that your velocity is 20 meters per second, 45 degrees from the east. Or because 45 degrees, another side is also 45 degrees, so that means this direction here is exactly in between the east and the south. So you can call this one, your velocity is 20 meters per second southeast. Okay, southeast. That is one way to tell people your direction. Other than that, you can also refer to the north line. Okay, to the north. So this one is the north direction, and this one is 90 degrees. So total out, 90 plus 45 is 135. Using bearing method. Normally you learn in maths last time, the bearing always start from the north. Okay, so calculate from here until here, that will be 135. So you can also specify your direction of velocity by saying that your velocity is 20 meters per second at a bearing of 135 degree. Okay, that is one way. But in physics, we normally adopt the component method. Later we look at the component method. Okay, so these are vectors. Okay, so you see it's a much more complicated procedure in solving vector equations compared to scalar quantity. Alright, so what can we do with vectors? Okay, so vectors, okay, we have a few operations. Okay, operation of vectors. Operation of vectors means what can you do when you are given two vectors or more. So we can do a lot of operation. For example, operation number one is summation, or normally we call it addition. You sum up two vectors. Okay, and then number two is subtraction. Normally this one refer to minus. Okay, you minus a vector from another vector. And then of course number three, we have multiplication with constant. You multiply a vector with a constant. And also you can multiply or multiplications with a vector. You multiply vector with vector. So that one is of course one of the most difficult one, because under multiplication with a vector, you have two types. You have one called dot product, another one called cross product. Okay, another one called cross product. Well, anyway, this one is not in your syllabus. Okay, I can't find any in your syllabus, but I'm going to teach you this one because you're going to become a future engineer. So future engineer, don't tell me that you don't know the process called dot product and cross product. Okay, because this is the basic of knowledge that you must know, so that next time you can extend your knowledge. Don't go to higher study in your engineering and then you tell your lecturer next time, Mr. Ho didn't teach me because it's not in the syllabus. People will laugh at me. Okay, so that is something that you must know. Alright, maybe some lecturers don't teach that because they strictly follow the syllabus, but I feel that is important. Okay, so look at that after we finish the more basic one. So now we look at summation. What can we do in summation when you are given two vectors? Okay,